Good day and welcome to the solution of the puzzle which was called Stars on 45. It was published April 25th of 2024 and it turns out it is a well-known puzzle, but it is a very nice result. It features a square with a diagonal and a red rectangle, and the angle shown over here is 45 degrees. And the question was to find the red fraction, so what part of the square is covered by the red rectangle. And I'm going to take the approach of Matthew Arcus because it's quite elegant. First of all, I'm going to draw some perpendicular lines. Let's make visible the points. And I draw a perpendicular through here. Let's see, I draw a perpendicular through here. And I extend this side as well. I hope we have enough here. First of all, let's name some areas. This obviously is a square, yeah, because we have here 45 degrees, so we have a square. Let's say it has area A. Then again we have a square over here, again with a diagonal, so 45 degrees, so it is a square, so it has area B. And finally we have a little square over here with area C. And the first thing I'm going to show is that B equals A plus C. And that is also quite a well-known result. But one way to prove it is to see that over here we have an isosceles, I must say. Thank you, Marshall Buck, for pointing out that I mispronounced isosceles. So here we have a isosceles right triangle, like here, and here is a 45-degree angle, so that implies that we can draw a circle like this, yeah, because this angle is twice the angle over there. We have a isosceles triangle, so one can show that. Oh, I think I not quite. It doesn't quite match up. Let's redraw it. The point must be exactly. No, my fingers are a bit thick today. Let's say. Yeah, now it's exactly at the intersection, and now I can draw the circle. Yeah, and now it goes exactly through this point and that point. But because it is a circle, we know that this distance equals, well, we already knew it's a square, so it equals that distance, but also the radius is over here. So that's, these three radii are the same. But now you can slide this little square C over here, you can slide A over there, and you know that the B, this is the side length of B. And you can apply Pythagoras to show that A squared plus C squared is B squared. So there you have the result. Let's make it explicit that A plus C equals a B. Yeah, that's an important intermediate result. Now, back to the full square. Another thing we use is a quite old lemma of Euclid himself, which states that if you have a rectangle and a diagonal, and there are 4 rectangles to a point on that diagonal, so like here we have the full square and we have a rectangle over here, we have a rectangle over here, well, it's a square but it's also a rectangle, and we have one over here, and we have one over here. Then from Euclid we know that the 2 opposing rectangles have equal area. One can easily show that, but I leave that to the viewer. So we know that this rectangle, let's say it has area x, that area x is also over here, so x is also over there. Well, we can apply that same Euclid theorem to this rectangle, because also here we have a diagonal, and again we can say that the 2 opposing rectangles are of equal area. So let's say this has area y, then we know that this rectangle also has area y. So, well, now we're almost there, because what you can see is that the red rectangle is made up of x plus y plus b. And, well, because we already knew that b equals a plus c, we had that over here, we can see that the remainder, so the gray area, is a plus c plus x plus y. And that is the same because of this equation. So we have found out that the gray area is equal to the red area, and therefore the red fraction is exactly 1/2. And that concludes the proof of the puzzle Stars on 45.